It's been a sunny week of weather, but as we inch closer towards the winter season, that sunshine is going to be much harder to come by as we enter some of the dreariest, bleakest, and cloudiest days of the year. Meteorologist John Burchfield in this week's edition of the Climate Friday newsletter, we're going to get you ready for Thanksgiving and the latter half of November, and in particular, talk about that sunshine, just how common it is this time of year and how uncommon it is going to become as we move towards December, January, and February, statistically the cloudiest days of the year. Good to have you here, whether you're watching on YouTube, WTOL.com, social media, or any number of places. You can subscribe to the Climate Friday newsletter online at WTOL.com/email. So let's break down the science. November sunshine, as well as fall and winter sun, and what the data shows us, and just how uncommon sunshine is going to become as we move towards the fall and winter season. During the winter season, sunshine becomes increasingly harder to come by, and over the course of the winter, only 1 out of every 4 days features full-on sunshine. In other words, 25% or less of those days are filled with sunshine, and cloudy and gloomy days become more commonplace. Now, this November so far has actually told a very different story in terms of the sky cover. Looking at our cloud cover so far for the month, 0 days with full-on overcast skies, which is highly unusual as we kick off November. Partly cloudy days have been somewhere in between, but overwhelmingly this week of weather has brought an abundance of sunshine with numbers in the double digits for the total of sunny days this month. That is not something that we typically see, and you have to go all the way back towards the end of October to find our last full-on cloudy day, October 29th. That was the last time that the sky was totally obscured and we did not see any sunshine due to the cloud cover. All of November has been a bit brighter and a bit milder as well in terms of the sky cover. Now, last winter falls within that framework of the 1 in 4 number I gave you. Only 22% of the days during the entire winter season leading up towards this year were sunny. In other words, sunshine becomes less likely as the days become shorter and colder and the sky becomes more overcast. Less than 1 in 4 days all of the winter season brought full-on sunny skies. Looking at the last 4 years, you'll find that those numbers are remarkably consistent. Last year, 2022 through 23, less than 1 in 4 days was filled with sunshine. The year prior, 24%, only marginally higher. The year before, 2020 through 2021, we were a little bit higher at 26% sunny days, and the year prior to that, 23%. You'll notice not very much room for error there, as we are all in those low 20s to mid 20s with sunshine not all that common. So let's talk about some of the weather and the atmospheric ingredients that cause those cloudier days in the winter, and why we can't just get all that sunshine that seems to be commonplace during the summer. Let's talk about the weather ingredients during the summer that typically feature very warm air near the Earth's surface. And there we got Fifth Third Field, just to get you thinking of those warmer days at the ballpark. When there's warm air near the ground level and the cooler air is way high up in the atmosphere, that causes more sunshine as that warm air rises and disperses any hopes of cloud cover. So warm air trapped near the Earth's surface generally is conducive to getting those bright, sunny summertime days that we associate with blue skies and high pressure. And there you have it, sunshine more commonplace during the summer, as well as the early autumn and the spring as well. Now, the opposite is often true during the winter season, and that's a different scenario where there's cold air trapped near the Earth's surface, which is not surprising given how much colder winter temperatures are. Oftentimes during the winter, the warmer air gets lodged higher up in the atmosphere, and when this occurs, where we have cool air near the ground and warmer air aloft, that is called an inversion in the atmosphere. In other words, things are flip-flop versus what they typically are during the summer. That cooler air is more dense, the warm air is less dense and rising, and that boundary between the warm and the cold air typically forms a layer of cloud cover. Now, it's not just any clouds that we often see during the winter time, but these are often those thick gray stratus clouds. That is a type of cloud that is often very flat and it's mid-level, so those ones really obscure the sunshine more than those wispy cirrus clouds that occur way up high in the atmosphere. In addition to the inversion being more common during the winter time, we see a different difference in the jet stream. Let's talk about winter clouds and the relationship to the jet stream and how we often get a more active storm track that brings us cloud cover. Low pressure systems ride along that jet stream coming in from the west-northwest, and when we do get lows across the Great Lakes region, that is typically associated with an increase in cloud cover. During the summertime, we are often under the influence of high pressure, which brings us sunshine. Now, once those lows finally do move off to the east, that often opens the way for a little bit more sunshine during the winter time as that jet stream eases up. But so long as we have an active storm track or an active jet stream, it doesn't really have to bring us much in terms of rainfall or snowfall. Sometimes the biggest impact of those lows moving across the Midwest region do come in the form of just some pesky, persistent cloud cover. Now, while we're on the topic of sun, let's talk about sun angle, because that is something we notice very commonly this time of year. You may notice during the summertime, boy, that sun feels toasty, it feels hot, and if you're out in the midday sun, you burn really easily. The sun during the winter time is much less direct, and the angle that it strikes the Earth's surface is not quite as steep. The biggest determiner of the weather that we have during the seasons, not actually how close the Earth and the sun are together, but it's how steep that sun angle is, and that's the reason it's hotter in the summer and colder in the winter, not so much due to the proximity to the sun, but because of the rays becoming more direct during the summer. During the peak of the summer season, the sun's rays strike Earth at a 72-degree angle. This might be a flashback to high school geometry, but that 90-degree angle is perpendicular. So if you think about it, 72, that is awfully close to perpendicular. At the equator of the Earth, they actually do see that perpendicular sun angle. That's why it's so hot towards the center of the Earth. Now, in looking at the less direct rays of the winter, our current sun angle, if you're watching this on Friday, is 29 degrees. That is a much more indirect sun angle as opposed to that overhead sunshine. That's the reason you don't burn quite as quickly during the winter season, and that's also the reason why temperatures don't warm up quite as much with that sun angle. Here's a little visual looking at downtown Toledo. The sun's rays are less direct during the winter time, and during the summertime we get that more overhead sun angle that causes hotter temperatures, longer days, as well as more sunburn concern. And during the winter, the rays are much less direct, splicing at less than a 30-degree angle right now. But as we get past the solstice of winter, we are going to see an increase in the sun angle. In addition to that sunshine, we're talking about daylight being lost in those evening sunsets. Sunset time, if you're watching this Friday, is at 5:12, and the earliest we get at 5:03. So really covering all those different aspects of the sunshine and how it impacts our weather during the winter season. Now, last week I promised we'd touch on Thanksgiving and get you prepared for the holiday. And let's talk about last year's Thanksgiving. It was a very mild day. Unfortunately, we're not likely to be quite that warm this Thanksgiving. You can see the latest forecast in that WTOL 1110 day. We got up to 62 degrees last Thanksgiving, and that was near record levels. We did see a few PM showers, but overall, it was just a very warm day. We averaged 48 degrees on Thanksgiving, and this year could actually be a little bit colder than average after that balmy 62 that we experienced last year. So looking at Thanksgiving records, the record is 68 degrees. That was set way back in 1896, and that was very early on when we started taking weather observations. So last year wasn't quite a record, but it was close. The most snow that we've ever seen on Thanksgiving, that was in 1902, 2 inches of accumulation. Don't worry, we're not expecting any accumulation this Thanksgiving. In terms of rainfall, a more recent year, 2010, brought us 1.37 inches of rainfall, and the coldest temperature ever recorded on a Thanksgiving holiday, that was in 1930. Single-digit temperatures, 7 degrees. Yes, we're going to be on the cooler side of things this year, but not those single-digit temperatures. You'll see the latest 10-day forecast on air, and you can follow along and subscribe to that Climate Friday newsletter, WTOL.com/email, and we'll see you next time as we get you ready for December and whatever the winter season has in store.